That's so empty.
Yeah, hurry please.
Me too, can I go too?
Yes. Asks you to find your copy of Chapter 2 Linear Motion. So I'm showing you Chapter 2 Linear Motion. It's a big packet like this. So please either look in your science section and see if you have it. You don't need to get it out. You can leave it in there. I just want you to double check and make sure you have one. If you don't have one, I have a few extras. Not enough to give everybody one, but I have some extras. Alright, thank you. Okay, so now you need the packet that's about the rollerbladers.
Leave that out.
And something to write with.
What was that?
We're going to do to finish it up together. So if you'll remember back from Saturday, we had an exciting opportunity to go out in the hall and watch Mr. Little and Miss Stein on their rollerblades. And they had kind of different styles of skating. They had different skates. If you remember some of the details from Saturday. And what we were talking about on Saturday, we were looking at how did they get themselves started? How did they keep going? Like how did they coast? How did they keep gliding down the hall? And then how did they help themselves stop without crashing? And we were sort of talking through, I remember Yael brought up the good idea of like a gliding foot and a pushing foot. So I remember that being an idea that a lot of people were interested in, his idea about how he saw Mr. Little pushing with one foot and gliding on the other foot. I also remember people talking about like that Mr. Little had to keep himself pushing in order to keep going. If he stopped pushing, then he would stop going eventually. And then I remember Liliana helped us create a graph, and that's where I want to start today. So if you'll flip to the page where you have your graph. Yes. Okay, so Liliana walked us through some ideas about combinations of constant speed diagonal lines, and then flat lines where people were stopped, and then diagonal lines where people were coming back towards the viewer, like back towards the audience. Okay, so I want to add some more detail to your graph because there's a new shape for the graph that I haven't taught you yet. So we already know three shapes. We know diagonal line of constant speed going forward. We know diagonal line of constant speed coming back at you. And we know flat line of something stopped. So I'm going to add one more line to your shapes. Okay? Okay, so get ready. Okay, so you might want to use a different symbol for this line. If you have different colors, you could use a different color. If your graph is blank, then you're in luck because you can just add this line. Okay. All right. So we saw, I'm having you imagine back to when Mr. Little was like at the beginning of the hallway and he was stopped. So he was at 0 meters, 0 time at the very beginning. Okay, think back and then raise your hand when you can do this. Think back and imagine, like, what were the first maybe like 5 meters of his motion like? 5 meters is about half of this classroom. Okay, so think back and see if you can describe, like, from 0 to 5 meters, what was his movement like? So I'm going to give you a moment to think back and remember what his movement was like. Okay, Hanad, can you describe it? What was it like?
His movement was like slow because like he was just getting started and he was just pushing himself, so like he couldn't have been at a constant speed and he couldn't have been going fast, and only when left over was going slow or stopped. So.
Okay, so you're saying that he was going slow to start with, and that he hadn't like made it up to a constant speed yet. He was like getting to a constant speed. Okay, that's exactly the movement that I want to teach you a new line for representing. Okay, so remember, constant speed, when Samson was walking, Samson could like immediately start at a constant speed, and we could draw it as a line like this, like straight, perfect diagonal. But that's not Mr. Little's motion. Like, he was slow, 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 and then getting like a little faster, a little faster, a little faster. So instead of being a perfectly straight line, does anybody have an idea of what kind of shape it might be when he's going like slow, slow, and then a little faster, a little faster, a little faster? Bradley, what are you imagining?
It'd be a curvy line.
Tell me what you mean by curvy.
Like when he goes slower, or when he goes faster, he like gradually goes slower. Then when he starts to slow down, it kind of curves down. And it goes back up.
So are you saying that, like wavy?
Yeah.
Okay. Hanad, what do you think?
I think like kind of wavy too, because like when he starts pushing on one foot, the other one gets slower. So like he's not like going fast, and he's going slow in the beginning, and then he starts getting like regular.
Okay, so now Bradley and Hanad, look up here for just a second. Now you're imagining wavy. Wavy to me means that he's going forward in position and then backward a little, and then forward a little in position and then backward in position.
No, like, I think like down, in, like a little.
Oh, like a swoop.
Yeah.
Okay, so that makes more sense to me. So something like that, where it's like a second goes by and he's barely moved any position at all. 2 seconds goes by, maybe he's finally made it to 1 meter. 3 seconds goes by, that's it, thank you. 3 seconds goes by, now maybe he's getting up to like 2 meters. And then 4 seconds goes by and he's finally now maybe up to like a constant speed. Okay, so can everybody see the difference between like the part of the graph that's a swoop and the part of a graph that's a straight line? So the swoop is what a physicist would call accelerated motion, and the straight line is constant. So the new line that you now should have in your mind is you're adding a new line, that anytime you see something that looks like a swoop, you should be thinking acceleration. And then anytime you see like perfectly diagonal straight, you should be thinking constant. I remember that he would then like stop for just a little bit while he was changing direction. So stopped, you guys already know stopped is when it's flat. And then when he would change direction and come back at us, what was it like? What was his movement like when he would, it was sort of like starting, you know, he was 10 meters away, but he was at the starting line again. He had to get started again. So, Jael, can you describe it? What was his movement like when he came back towards us?
The same as that, but like instead of that, like the swoop thing is on from top to like halfway point.
Like this?
Kind of. And then the constant speed is just like straight down.
So you're describing like that it would be another place where it's accelerated. And so you have like a little bit of a swoop. It's not, I didn't draw it very exaggerated, so it's hard to see. And then another place where he was finally going constant. And then maybe he decides to stop. Like,
So we should start off with like a swoop when there's like something that has to do with like wheels or something. Not
like when it's something, so tell me what you're imagining when you hear the word accelerated or acceleration.
going forward.
Just forward?
Well, just going in a direction, just moving.
So when Samson was walking, like and keeping a beat, and he was walking at a constant speed, just because he's going forward, you're saying he's accelerating? From, compared to like when he was stopped?
Yeah.
Yeah, okay, that's true. Like from stopped to going forward, he's accelerating. But what else could accelerated mean? Like for Mr. Little, he was still accelerating even in the middle of this swoop. So what does the accelerating mean in that case?
The speed.
Yeah, say more about that.
How like the speed per second.
Well, yeah, like he's gaining some speed
Yeah.
each second. Yeah. Okay, so the swoop is for any time when it's like going from 0 to getting moving, and then it's moving like gaining some speed.
From 0 to constant.
Yeah.
Okay.
And you could imagine like maybe something might be able to accelerate for a really long period of time before getting to its constant speed.
Okay.
Okay, are you ready for me to blow your mind a little bit?
Yeah.
You ready for your brain to explode a little on the inside?
Yeah, I'm ready for it.
Okay, you ready? All right. So, okay, here is the puzzling question. Okay, can you imagine it being possible to be at a constant speed but still be accelerating in physics? So think about it for a second. This is the part that's going to make your brain explode a little bit on the inside. Okay, is it possible to go at a constant speed but still be accelerating? So like, would it be possible to go like 5 meters per second forever, but be accelerating forever?
So speed change like.
No, like you're just staying at 5 meters per second,
Wouldn't you be
but
like?
accelerating. So wait, hold it in your head. Okay, so if you have an idea, I want you to turn to the person next to you and share your idea. If you don't have an idea, I would try to listen to your neighbor and see if that helps you get an idea of, is it possible to go like 5 meters per second without changing that, but to be accelerated?
As a human.
So first let's definish what acceleration means. Acceleration means like when you're going. Yeah. So like you don't. So if you're like right here, your acceleration when you keep on going faster and faster and faster. Like when you're gaining speed. Yeah, but then when you have a constant speed, well then you just keep going that same exact speed. Yeah, but but how can you be going at a constant speed? You said you're going at constant speed forever and then you gain a speed. You can't go to constant speed if you're gaining speed, and that means you're not gonna go at constant speed. Your speed's gonna change. Technically, you're not. So you can't do that. So you can't. But then, wouldn't you be two separate things? Wouldn't you still be accelerating? I don't know. Wouldn't you still be accelerating when, like, from the beginning spot? Because, like, in the beginning spot, you're not gonna constantly go 5. Because, like, it's not possible. Because you're but if you want to go 5 forever, then you can't gain speed. So you can't accelerate. If
I don't
you're trying to go a
think
constant
that
speed.
acceleration means gaining speed.
Yeah. So that means you can't accelerate if you're trying to go at a constant speed.
Not when you,
Because if you're trying to go at a constant speed, then that means
you'd be like,
that you.
So Hanad, you are just dying to tell me about this constant speed but accelerated. So tell me a case where you could be going like 5 meters per second constantly but accelerating. You think it's totally impossible?
Yeah,
How
because
come?
like when we're reading the packet on page 8, it says if Ringo maintains a steady speed, his acceleration is 0, because like acceleration is like where you're like moving, but then you're not moving across speed, you're like changing, like you're going slower, you're stopping, you're going faster. So I think that you can't accelerate and be at a constant speed at the same time.
Okay, so Hanad has made a little argument for that my scenario cannot happen. I think it's impossible to do the thing that I said. Is there anybody that wants to make another argument? Liliana.
Well, if it's a robot, you can.
Okay, tell me more about robots going 5 meters per second but accelerating.
Okay, well, maybe like someone can program it so it can automatically go at the same speed, like constant, so that like it would keep going.
But then how is it accelerating if it's going at a constant speed?
Well, I don't know.
Okay, Bradley, what do you think?
Maybe at the beginning, but if you're just counting the part where they're at the constant speed, it would be impossible because your speed is not changing and that means there's no acceleration.
Okay, how come?
Acceleration is like when you speed up, kind of.
Okay.
And your speed is not changing at all, and you're not speeding up or slowing down.
Okay.
And so, yeah.
Okay. Destiny?
I agree with Bradley, like, that, like, you can't accelerate while you're going at a constant speed, because, like, if you're going at a constant speed, that means that you're not changing your speed, and you're going the same speed for however long you're going. And when you're accelerating, you're like gaining speed and like it's kind of like changing your speed.
Okay.
And so it's like two different things. You can either accelerate your speed and gain, or you just go at one speed.
Okay. Is there anybody that would like to make the opposite argument? Is there anybody that has an argument for I can go 5 meters per second constantly, but I can also accelerate? Helena? Okay, what's your argument?
In the argument, like what?
I disagree.
Okay, so listen please, because this could be really important if she has evidence that'll go against everybody else's argument.
Because, for example, Mr. Little, he was going at constant speed, but he was accelerating because in the beginning you can't go at a constant speed.
Okay, so you're saying like at the time at the beginning when he starts out at 0, before he gets up to 5 meters per second, he has to accelerate to get up to the 5 meters per second.
Technically you're accelerating if you're going.
What about just during the chunk of time when he's going 5 meters per second? Is it possible for him to go 5 meters per second constantly, but also be accelerating?
Well, no, not
Okay. Jaden, you get the last word.
It might be possible.
Okay.
I'm kind of in the middle.
Okay.
But pretend if this was 1 meter and this was another meter, and this is the car.
Yeah.
And then it's driving. It could like turn.
Okay.
If it was turning, it could. Never mind.
Okay. So here I'm gonna give you a little scenario. What if?
Exactly.
What if Mr. Little goes constantly at 5 meters per second around and around and around this circle? Okay, I've heard a lot of people say acceleration is changing speed in a certain amount of time, but is it really changing speed in a certain amount of time? Okay, so what did you guys learn from all the stuff that you read? Like what is acceleration? Helena, what do you think?
Well, like, it's not only, acceleration is not only just speed, it's like mostly like motion too, so like you're accelerating like motion and like on a packet. I remember like on something where you're accelerating but you have no motion at all.
Okay.
So like there's different stuff. So if you're turning, you're kind of acceleration because like you're turning but you're not going a constant speed of 5.
Oh, okay. So you're saying like when he's going around this, he might not actually be going 5.
Because he might be
Okay.
5 right now, but then when he's turning, the motion will change.
What if he's like so good that he can stay constantly at 5? Is he still,
Yeah,
is this still accelerating? Why?
because the motion is changing.
Well, tell me what you mean by the motion.
Like the way he's like, first he goes like this, and then when he's turning his, like.
What if he has like jetpacks on his feet so that he doesn't actually have to move his feet? He can just like stand there and go 5 meters per second in a circle.
I know it's not how fast like his wheels are going, or it's how like he's still kind of like accelerating motion. Is like you're moving, cause like you're going in a circle, so there's gonna be corners, so you're gonna have to turn.
Okay. So what is it about the turning that makes it be accelerated?
I can't laugh. It's, oh God, it's hard to explain.
Clayton, you're just dying to tell me something. Go ahead.
Oh, I get to go?
Yep.
Obviously.
And then Amy,
And, like,
she's been dying to tell me something
In
too.
this, like, it says acceleration, they define it as a change in velocity.
Uh-huh.
And then on the left
Is that what you were going
side,
to say? Yeah.
on the left side it says velocity represents both speed and direction. And that's all I had.
Okay, so Amy, what would you say?
I agree with Clayton.
So like, how is this picture that I drew, Amy, does this picture represent constant speed but accelerating?
Yep.
Why?
Because like they're changing the direction like whenever they move because they're moving in a circle and the circle has like infinite number of sides.
Yeah. So like, he's going, if we count like this as being positive and this as being negative, he's like positive and then like kind of positive, kind of negative, kind of positive, kind of negative, until finally he's negative. So he's like, every single time that he makes any move, he's changing direction. Okay. Okay, so this is the part where I told you I was going to make your brain explode a little bit. So on the graph, I'm going to pick out, like, not only do the swoops show acceleration, there's a couple of points on this graph that also show acceleration. Like, instants in time where he's accelerating simply because he's changing his position, like changing his direction. So for example, like right here he's making a change in his speed, right? He's going from like constant speed to being stopped. Okay, but like somewhere in here he turns around and faces the other direction. Those are moments of acceleration. So even though he might be like sort of standing still, he's turning his position, and those instants in time are considered acceleration in physics. Weird, right?
Acceleration.
Making it hurt a little bit.
On the graph. We're doing a little bit.
So if you remember on the question of the day from Saturday, I had you guys thinking about what acceleration means in like talking about every day about a car or something like that versus acceleration in physics. This is the stuff that I'm trying to help you understand that's special about the idea of acceleration in physics. The acceleration in physics is not just about speeds. It's also about your position, like what direction you're going. Okay? So it makes possible these crazy ideas where you might go a constant speed and also be constantly accelerating.
I was right.
Which seems crazy at first. Like, in fact, half the class was arguing strongly that it was impossible to do.
You are wrong. Except me. I was disagreeing.
But now I'm hoping I'm starting to get you to reconsider that it is possible to go constant speed but accelerate. Clayton.
So what if we wasn't going in a circle? What if we were going in a straight line and never turning around? Can you be accelerating then? Or no?
If you were, so you're saying like, if he's going 5 meters per second forever.
Yeah, he's going to Florida and he's not like...
He's not ever changing his speed or his direction. What do you think?
No.
Why?
Because velocity is the speed.
So you're saying like, he's tired of all the snow, he's going 5 meters per second south forever. What do you think? Is it possible that he's accelerating? I agree. Okay. Okay, here's what I would like you to do. We have 11 minutes left.
Oh, what?
I know, it's crazy, right? It goes so
As
fast.
long as 1 to 5 minutes.
You were going for a long time.
Okay, so I need your attention up here, please. Okay, in the next 11 minutes, I would like you to try to get 2 things done. Whatever you don't get done, you should add to your homework. Okay, so it's in your best interest to move fast for the next 11 minutes. Okay? So the first thing, with your name neighbor or your partner, I have 4 bullets of questions to try to help you explain what you saw going on with the rollerbladers. Talk it out first if you want, and then write down what you talked about. Okay, and then on the back, just like we did with the carpet and the blocks, I want you to imagine if you could zoom in and get down here underneath one of the wheels and could zoom in, what would it look like where this wheel is touching the ground? I heard people talking about like pushing or the like,
Draw
yeah, you can draw, you can zoom in like I did. You could, I just want you to represent like what do you think is happening between the wheel and the ground? So talk about that a little bit. How did he get himself started?
So wheels like this, it can roll perfectly fine. But if it's like this sliding, these can't roll this way.
Yeah.
So then they're rubbing against the ground in a way they can't roll.
Yeah.
So then he can push off where he's getting gripped onto the coasting foot, and then switch off.
Yeah.
And then like how does he keep himself going?
He goes grip, non-grip, grip, non-grip. I have no right.
Okay, and then if he just like rolls for a little while, why does he stop?
Technically, if you rolled something, it would keep going forever unless another force stops it or something.
Okay.
But there's friction on the wheels and the ground, so then it stops.
Does that count as the other force that's stopping him?
I just need to know the concept.
So like what if we lived on a planet that didn't have any friction?
Then you could go forever unless it's
Exactly.
So you're saying maybe gravity has something to do with it too, like pulling you down has something to do with it too? Okay, so I heard grip, I heard pushing foot, I heard gravity and friction. Make sure all those ideas get in there. Okay, what are you guys putting in your pictures?
Okay, so his idea was that the floor was like not completely straight. It was like
Because there's like bumps of like crumbs and like
dust and stuff.
So I thought that it wasn't fully touching the ground. Like
That the wheels aren't fully touching?
it was mostly touching like the crumbs and stuff.
Okay, and then how does that change or affect the way that he was moving?
well, because so
I think it would like make him slower.
Why is that?
Like if there's like ticks on like
Is it like that there's like little tiny obstacles to how he's moving? Okay.
yeah, and they're like making like if I were to like walk across a room with like a bunch of like breath mints on the ground, it would take me way longer than if I was just walking across a room with just
Oh, okay. Because like something's in your path?
exactly like with this wood floor, it's like easier to walk on it like with socks and just slide through it, unlike if it was like more concrete floor.
Okay. So can you also, in your diagram, can you represent like the, I heard you guys earlier talking about grip, stuff like that. Can you like represent the grip? Like what do you mean by grip? Okay. Or like your group was talking about the tension between the skates and the floor. Can you, I know, all my why questions. So can you maybe, since I don't understand what you mean by tension, could you like draw in what you mean by tension? Okay.
You know Christine is mean.
Not understanding it? What about you? So. Okay, so let's start from the very beginning of his motion and talk about it, kind of like telling the story. So like, how did he get himself started?
so I wrote that here.
So yeah, tell me it.
I said to start, you have to push yourself with one foot and glide.
No,
And
like
you have to have lots of energy in starting yourself off. And then,
I might have been late.
Okay, so let's just go with those two ideas about the pushing and the energy.
I've been
Okay,
late.
so tell me in here, can you tell more about like why the pushing gets him moving?
The pushing because it gets the skates rolling.
Okay, well it gets the one skate rolling, right? Like how Jael was talking about the pushing foot and the gliding foot. So it gets like the gliding foot rolling, but what is the pushing foot doing?
The pushing foot kind of like supports the gliding foot.
Okay.
So it like supports you so you can keep moving.
Okay, so like to move himself forward, which way does the pushing foot
Does it have to go backwards?
That's what I saw, right? Like that he pushes like behind himself,
So like
and that makes the rolling foot go forward a little bit.
And to like force yourself to go
Yeah.
forward.
And then how does he keep going forward?
He could change like positions in moving his foot from pushing and gliding.
So he like trades feet. Like he'll put the pushing foot down and glide on that one, and then push with the other foot, right? So you also use the word like forces himself to go. I like that idea too. So I think you could write like a little paragraph about the pushing idea, and then maybe write a little bit about your energy idea.
So could I start off my sentence like the person's motion
Changes because, yeah.
changes because
Or you could say like person's motion starts or something because.
Oh, wait, so when you say motion, you're not talking about like, you're talking about what happens like to the feet? Or
Like to his whole line of movement, that he goes from being totally stopped to being moving, to being like moving even
so you want us
faster.
to tell how you get the motion started, then how do you get the motion to keep going, and then how do you get the motion to stop and then restart?
You could just go from starting to stopping.
Oh, I said because every once in a while they change direction. I thought you meant like.
Oh, well that's true too, but no, I like Sydney's idea and your idea about pushing and gliding.
So like the person's motion changes because the force from one foot and support from the other.
And then you can talk about how we talked about pushing backwards makes you move forwards.
So it's because of the force of one foot.
So Liliana, can you, besides just drawing the wheels bigger, can you tell me about what's going to go into this drawing? Like what do the lines represent?
Okay, these represent the speed, like the speed it's going. So like once it passes the ground, or once it passes something or somewhere.
Yeah.
Like it's gonna leave like a little bit of wind.
Okay.
Because like it goes fast.
Yeah.
And then
What are these lines? That are like in the front of the wheel?
well, they're like some things stick up off the ground, and so like this.
Like that if you were zoomed in, you would see them, but we don't see them
Yeah.
like most of the time.
And like once the wheel passes, they'll get flat because
Oh, okay.
since the ground is flat, this is circular, so it will like run it over, and then it'll get flat.
So then when he's, like, if he just coasts, you know, if he just glides without pushing anymore, what do these do to the way that he's moving?
Well, they would be down, but like they wouldn't be completely flat. They might pop back up.
Do they get in his way at all?
Well, not that much, but it will make him like not go super fast.
Oh, okay. Would it eventually make him, like, is that why he starts to slow down?
Well, maybe it's not just because of that. Maybe it's because the power it happened at first doesn't stay forever because
If
like,
he stops pushing?
Yeah.
But then why does he slow down?
Well, because he stops pushing.
Yeah, but why does he slow down? I mean, why can't he just, like, roll forever?
Because he doesn't have enough power.
Okay.